Welcome back. This is course 20 of the Code to Vibe Academy. In course 19, you got the three features straight, right? Rules, always on standards in the agents.md file, workflows, command step sequences, and agent skills, description matched knowledge packages. And you wired all three up on the TaskFlow app. Now I want to revisit something from back in course 1. Remember the vibe coding spectrum? On the one end, there's pure vibe coding. Describe loosely, iterate fast, great for exploration. On the other end of the spectrum, there's spec-driven, written requirements, defined acceptance criteria, structured planning before a line of code is written. We've been living mostly at the vibe end of that spectrum. Fast, conversational, iterative. This is genuinely powerful. But there are moments when pure vibe coding is not enough. For example, the feature that we're about to create has multiple behaviors that all need to be precisely right. You need to be able to verify it, not by feel, but against a written list. The stakes are high enough that if it looked right in the browser, enough is not a good enough answer. This is the spec driven end of the spectrum, and Antigravity 2.0 has a clean pattern for it. It does not slow you down, it gives you a different kind of confidence. By the end of these 30 minutes, you'll be able to write a spec, use it to generate a structured plan, review the plan against the spec, iterate until it's right, and verify your acceptance criteria with the built in browser agent. Let's get into it. Okay, here's the decision framework, not a rule, but a framework. You'll use both modes on the same project often. Vibe when you're exploring, you don't know what you fully want yet. The feature is small and low stakes, or you're moving fast to validate an idea. The cost of being wrong is very low and easy to redo. You use spec driven development when the feature has multiple moving parts and dependencies. Other people need to review and approve or build alongside it. Or the acceptance criteria matters precisely, not something like this, but exactly this behavior verified. You're building something that will persist and be maintained. The cost of being wrong is extremely high or creates tech debt. Here's the practical test. Can you verify success by feel, or do you need to check against a written list? If it's feel, then use vibe. If you need a list, spec development. And here's the thing nobody tells you: writing a spec is still vibe coding. You're still describing what in plain English. You're just being more deliberate about completeness and verifiability. The agent still handles the how. The skill is knowing which posture fits the moment. Just like choosing Claude Code versus Antigravity 2.0 in course 8. Different tools, different moments, not one winner, just knowing the difference between the two. Okay, a spec doesn't have to be a 40-page document, right? A good spec for a vibe coding project is tight, clear, and verifiable. The structure I recommend has 5 sections. Number one, the goal. One or two sentences. What does this feature do and who is it for, basically? Then there's the context. What already exists that this builds on, if anything? What tech stack should be used? Are there any constraints, for example? And then requirements. This is a number or bulleted list of behaviors, each one specific enough to test, not something like it should look nice. Instead, the API should return a 400 with a field level error object when required fields are missing. Acceptance criteria. Given A state, when B action, then C result. These are the tests in disguise. And then there's the out of scope section, explicit about what is not included. This is the single most underused section, right? For example, this does not include task search or filtering by tag, prevents the agent from going further than you intended. Out of scope really matters. The reason is agents are helpful. Helpful sometimes means doing things you didn't ask for. The out of scope section is the guardrail. We actually saw this when we first asked Antigravity to build the TaskFlow application, right? We gave it a simple application, but it included things like gradients, it included things like a timestamp, it included things like the progress bar at the top that we never asked for, right? So when we say an agent can be helpful, that's what we mean. The structure that I just shared is my recommendation, right? It's not a built in feature of Antigravity 2.0. It's what I've learned from years of coding. It's a format that just works well for driving structured agentic work. Adopt it if you need it, right? The total length of a good spec, I would say a few hundred words at most. Enough to be precise, but not so long that it introduces ambiguity. Okay, here's the core prompting pattern for spec driven development. And here's an example of what it looks like. Act as a lead engineer. Read the following specification, produce an implementation plan with numbered tasks, estimated complexity for each, any risks or open questions, and the sequence you recommend. Do not write any code yet, only plan. Why act as a lead engineer? Well, it sets a role and a quality bar for the agent. A lead engineer reads specs critically. They ask clarifying questions. They surface problems before they are problems. You're asking for that posture, not just the output. Why do not write any code yet? Because you want to review the plan before execution begins, right? This is the implementation plan discipline from course 7. Apply it at a higher formality. The plan is a real anti-gravity 2.0 artifact that you review, you comment on, you approve it just like any other plan or make adjustments. What a good plan response looks like. Each requirement gets a task. Each acceptance criteria maps to a verification step. Risks are named. This requires, for example, a schema migration test coverage for the migration script is recommended. Open questions should be flagged. For example, if the spec says optional note, then it should be flagged should any empty string be treated as a note or stored as is. All right, here's the last one, the open question. That's exactly what you want. The agent caught an ambiguity in the spec before any code existed, right? Your answer to that question is worth 10 minutes of debugging later. This is the cheapest moment in the project, right? A question in the plan costs nothing. The same question discovered mid build costs rework. Okay, now you have the plan. You don't just read it, you review it against the spec. Here's the review checklist, right? Number one, coverage. Does every requirement have a task in the plan? Go through them one by one. No requirement should be taskless. Should be taskless. Acceptance criteria. Does the plan include a verification step for every acceptance criterion? Build it is not enough. Build it and verify that it passes is what you want. Out of scope. Does the plan include anything that was explicitly ruled out? This is easy to miss and costly to discover later. Then there's the order that the work is going to be done. Does the sequence make sense? If task 4 depends on task 7, that's a problem to catch now. And then the risks. Did the agent name any risks? If there are obvious risks the plan does not mention, note them before approving. Tactical move, right? Put the spec and the plan side by side, go through the spec requirements one by one, find the corresponding plan task. If there's no match, then you have a gap. What to do if you find a gap? Well, leave a comment or send a follow up request to your agent. The spec requires the note field to persistent SQLite task 3 does not include a migration step. Please revise the plan for an example. All right, the revision is fast. The plan is text. Revising a plan before code is written is trivially cheap. All right, let's talk about iterating through a plan. Review the plan, send feedback, plan updates, and review again. Repeat until the plan fully maps to the spec. Remember, we're aligning the plan to the spec we provided. How many rounds does it take? Well, usually one or two. It's dependent on the spec itself. A well written spec produces a good plan quickly. A vague spec needs more iterations. All right, here's some useful feedback. If the plan that was developed requires 3 rounds of updates or iterations to get right, then the spec had gaps. Use that signal to sharpen your next spec. Here's another question. When is the plan ready to approve? Well, every requirement is covered. Every acceptance criteria has a verification step. Every out of scope item is absent. And every risk you care about is addressed. Don't approve a plan that you're not confident in. The discomfort of an uncertain plan is information, right? I'm not sure that's right, for example, means ask a clarifying question, not just approve and hope for the best. One thing to watch for in iterations is scope creep in other directions, right? You keep asking the plan to be more complete. Now it includes things you actually did not want. You want to check your out of scope section every time the plan is revised. Okay, you have an approved plan, and now the agent begins to build. You monitor mission control as always. As each one of the tasks completes, track it against the spec. For every acceptance criterion, there should be a corresponding artifact, a screenshot, a recording, a written result, for example. Give A state when B action, then C result. Show me the result happened, right? The built in browser agent is your friend here. Invoke it explicitly with each criterion as a scenario. For example, given the task list is loaded, when I expand a task with a note, then the note text should be visible. Please verify this and produce a screenshot. That's an example of how to verify with using the browser, right? Go through the acceptance criteria one by one after the build. Check it off as you verify each one. If one fails, good. A failing criterion before shipping is the whole point of having criteria to begin with. Then send a follow up. For example, criterion 2 failed. The note is not persisting after page reload. Please fix this. When all of your criteria passes, you haven't just built the feature, you've proven it meets the specification. This is a different level of confidence than I think it looks right. All right, let's head over to Antigravity 2.0 and do this for real on the TaskFlow app. Okay, here we are in Antigravity. What we want to do is add an additional note field to each task. We want to store the note in SQLite, surfaced in the single page app, and accessible via the REST API. That's essentially what we want to accomplish. We're going to use this spec in order to request that behavior from Antigravity 2.0. Remember our recommendation when you're doing tech driven vibe coding, you always want to start as a lead engineer. Okay. So act as a lead engineer, read the spec below, produce a plan, and don't start coding yet. And the spec basically has those 5 areas: goal, context, requirements, acceptance criteria, and out of scope. Okay, I'm not going to read all of that. You see what that says. I'll leave that on the screen, or you can pause the course right now so you can get that. You'll be able to download this spec from the Google Drive for all of the courses. Okay, so let's get this copied and let's start anti-gravity on completing our spec-driven vibe coding. Okay, so the implementation plan is done. We're going to let's open up our spec. We'll minimize that some and bring that to a half a page, and we'll open up our implementation plan in the other half of the window. So we can do it side by side, right? Because we want to validate everything. All right. And let's get anti-gravity. All right. Mm, yeah, there we go. Okay. Okay, so there's our plan. Now, user review required. We've carefully designed this feature to feel premium, responsive, and robust while maintaining compatibility with the exact system structure. Please review the following technical details: database schema migration strategy. SQL SQL-Lite tables may already exist on current deployments. Modifying the create table query is not enough. We'll dynamically run an alter table to-dos, add column, note, which is a text data type migration inside of SQL-Lite repository initialize. So they're going to run the alter script inside of the initialize script. Any errors where the column already exists, in other words, duplicate column names, will be caught and ignored, and that sort of thing. All right. And then it gives us a note. In accordance with premium single page app aesthetics, right? So it's using best practice UX design now, and it's communicating to us what it's going to do there. And then it has proposed changes, persistent layer, and UI presentation layer, and then the testing layer. Okay, so let's talk about the acceptance criteria. So our acceptance criteria is given a task exists. When I patch it with a note, then get returns the updated note. The second one is given a task has a note. When the server restarts, then the note is still present on the get. And then the third one is given the single page app is open. When I expand a task with a note, then the note text is visible, right? So the test that the implementation plan has put in place is number one, we're going to test creating, editing, and fetching optional notes on tasks. And then the second one is add a specific test case that simulates server restarts. This is where our server restart came in, right? So server restart here, right? So our agent is saying it's going to simulate a server restart by initializing a fresh SQLite adapter on a temporary database file to verify persistent recovery of node strings across process lifecycles. So it's going to test our acceptance criteria. And I didn't see anything here about the out of scope things. I didn't see anything about searching notes, character limits, or note sharing. So there's nothing, I didn't read anything in here about that. So I think we're good, right? And so what we're going to do now is tell Antigravity 2.0 that the implementation plan is approved and proceed. So implementation task, optional task notes, data validation at the service layer, right? Add a node schema validation. So that's the task it's going to do there. And then database schema storage layers, right? And then SPA front end layer, implement Chevron transitions and layout, and then support expansion tracking, detailed drawers, and API saves. And you can see our tasks are being completed. Integration testing layer, implement API tests for note creation, retrieval, and updating. Implement simulated server restart. So for our acceptance criteria, we do have corresponding tasks that align with what we wanted to say, right? So this one says when I patch a note, and this one says um, given a task has a note when the server restarts, and then this one says as I expand a task with the note, then the note text is visible, which we're going to see when we go through create, right? When that task is completed, we will understand that our criteria, all three criteria have been met. And there's nothing in here about, or there's nothing that the agent added that we did not include in our spec. In other words, it adhered to the out of scope specification that we listed. Okay, so we've got a bunch of artifacts, right? So I've successfully completed the task outlined in the approval implementation plan. And we can see all of the artifacts. Look at what we've got. We've got a walkthrough, we've got a task list, we've got, of course, the implementation plan, but we also have the QA report. Now, remember from our previous course, we created a workflow that actually runs QA. And what our agent has discovered is that we needed QA ran because we've added a feature. And so it has produced the report, and that's the first artifact I'm going to look at. So we can see ESLint and Jest tests have passed, all passed. So that's successful. We know our checklist, our task list, we looked at that. So those are all checked off and it aligns with our overall spec. And then we have the walkthrough. Now, the walkthrough is going to be the complete assessment of the feature after it was developed, right? This is the final document. So let's spend some time going through this, or let's just take a look at it. Um, yeah. So the document summarizes the technical changes, testing coverage, and QA outcomes for the task notes enhancement in the to-do anti-gravity project, right? All right. So data validation, data storage, front end, and then testing and validation. All right, so here's the tests that were run. We have a list of the tests that were run. Notes API integration. Here's our test, right? So here's a patch with a note, sets the note and get returns the note. So that passed. And then SQLite simulator server restart persists notes successfully. So we had 22 tests and 22 passes. And this is how long it took, right? And so our QA plus Jest plus ESLint has our testing every time we create a feature, and it's done automatically. That's exactly what we want to see with spec-driven development. Now, I do want to note one thing relative to our instruction to Antigravity 2.0 in the beginning, right? And that is, here's our spec, right? We did not tell Antigravity 2.0 to use subagents. So you'll notice it did not use subagent. It sequentially went through all of the tasks, checking them off one by one. They were dependent, and so it was important. But we could have asked it to use subagents to get the parallel, simultaneous, to get the parallelism of subagents and the efficiency of subagents. And so maybe in our next development, our next spec development, we'll request subagents. All right, here's your exercise. Write and execute your first spec. Take any feature you want to add to the TaskFlow app or your own project, something with at least 3 behaviors that need to be specifically right. Then write the spec according to the 5-section structure: goal, context, requirements, acceptance criteria, and out of scope. Send it with the lead engineer pattern. Review the plan against the spec. Catch at least one gap or ambiguity before approving. Build it, then verify every acceptance criteria. Use the browser agent to prove at least 2 of them with screenshots or recording. Share your spec and what the plan review caught in the Code Divide community on our website. Tell us, what would you have missed if you had vibed it instead of spec'd it? All right, let's lock in what you've learned today. You have the vibe versus spec decision framework. Vibe for exploration and low stake development, spec when verifiability and precision matters. Both are vibe coding, but different postures. Here's my recommended way to write a tight spec: goals, context, requirements, acceptance criteria, and out of scope. It's my recommended structure, not built in, right? It's short enough to be precise, but complete enough to verify, as we just saw. You use the lead engineer pattern, right? Ask for a plan first. The plan is a real artifact that you review step by step. Surface ambiguities before they cost your development. You review a plan against the spec: coverage, criteria, out of scope, order, risks, and so on. The cheapest moment to find a problem is reviewing that plan. You iterate you iterate on the plan until it's right. Then approve the plan and let Antigravity 2.0 build it. You read the plan and made sure it was correct. Then you approved it and let Antigravity 2.0 build it. You verified every acceptance criterion, looking at the test results, proof, not hope. Here's what's still ahead in Module 3. You've been running agents on a single model per mission, but Antigravity 2.0 lets you run different models for different agents on the same project. Gemini 3.5 Flash and Pro are both available now, and right pairing depends on the task. In Course 21, we go multimodal. How to pair Gemini 3.5 Flash and Pro strategically within one workflow. Plan with one, execute with another, verify with a third. See you in Course 21.